Hello, everybody. My name is Miroslav Mehic. I'm coming from University of Sarajevo, Bosnia and Herzegovina. And today we are going to present the Qkd Network Simulation model. Also, the simulation will be presented by my other colleagues online. So the first part will be presented by me and the second part by colleagues online. So we closely cooperate with VŠB Technical University in Czech Republic. They are helping us with a simulator. They have a very nice infrastructure regarding the supercomputer and experience. And based on this cooperation, we basically developed our simulation model. So let's go start. The presentation, as I said, will be organized in two parts. The first one is about the theoretical introduction. So I'm going to explain the fundamentals of the simulator, how we organized what we did and how we basically made the structure of that, how it works. And then in the second part, we will present some examples and show the demonstration, how you can use it and what is possible to do with the current version and also what we are doing in the rest of the project, focusing on the future work. So in the theoretical introduction, I'm going to start shortly about the timeline. As you know, within the OPENQKD project, we started basically in the beginning of the project, asking about the possibilities, what we need to design, what are the requirements to simulate, which use case will not be able to implement in practice, and how we can implement them in virtual reality, like the simulation. So for now, we submitted 3 deliverables, D62, D63, and D68. And now we are waiting for preparing for the final deliverable, D610, that will be submitted in 2023. So why Qkd Network Simulator? You're already familiar, and we heard from previous presentations about the simulations, but our view was about the network, not only on particular link or quantum phenomena, optical properties. So we focused basically how to design and create the network simulator. So how you can simulate the huge, large networks. And we started with this at the beginning of the project. The basic aim was then when finally you have the key, when you establish it using which other protocol you use or whichever equipment you finally decided to buy it, to rent it, to develop it, whatever, then they produce the key. And the question is how you want to use this key, where do you want to use this key. So the focus of the whole simulator, of the whole story, is about applying Qkd in existing networks. Basically, we said, okay, let's see and how we can apply Qkd in existing IP networks and also some other networks that go beyond. So the main aim is, of course, to understand the Qkd technology, that it's just additional security layer, and it's necessary to integrate it in the existing IP infrastructure. The current version of the simulator is already in version 3.4.3, and the latest patches. It's compatible with the NS3 version 3.35. So the main aim of this version, when we were starting developing this version, was let's develop something that is available currently on the market, the functionalities that are available on the market. Because yes, we can design whatever you want, we can simulate whatever you want, but we wanted it in this phase to have the version of simulator showing what is available on the market currently in production stage. The right picture on the slide shows the basically organization of the simulator. It's a class diagram already deliverable, submitted within the deliverable, basically showing the organization. I'm going to shortly represent and discuss the main components of the diagram and the simulator by itself. The first version of the simulator is publicly available. It's currently open source. We are also working on this version of the version 2 and version 3 also to make it open source. After the publication and after final testing, we aim also to submit one of the versions to be open source for the community. But the first one, that is basically without the structure that is defined inside of this consortium, is available publicly on the links. I think you already know them. You can download the virtual machines and you can play with some of the examples that are available. Okay, Why NS3? Well, when we started designing, I remember the meetings from the beginning of project. There were a lot of comments why to use NS3, why not to use some other solutions. Well, we found out that the NS3 is very powerful tool, and we have a lot of experience in it, and it's very, very easy to develop new solution in it. So it also supports additional functionalities. I will talk about that later. And it has a very nice community. So you can see the releases of the NS3 version of the background. It's continuously upgrading. So about after a couple of months, there is a new version fixing bugs and also producing the new version. So within the NS3 simulator, the core, we didn't change anything. We just introduced additional module, Qkd module, that allow us to integrate the Qkd functionality and play with the rest of the code. So having this in mind and focusing basically on the usage of the Qkd, we said in the introduction that the main aim was how to use the key. So we understood that the key will be produced, it will be generated, but how to use it, then what you want to simulate, what you want to play with it. Well, the main focus of the whole simulator about the network performances, network estimation. We are now currently discussing different network organization topology schemes. Also play with the network traffic management and also key management, quality of service as well, and integration of Qkd with other technologies like the 5G multi-path routing, and etc. The simulator is also used in another research projects like the NATO Quantum 5 project. It's supported by NATO SPS project started in February last year. And we also use simulator here for the application of quantum Qkd simulators, components and emulator components. We'll talk about that later within the 5G network in Czech Republic. One part of the simulator is also combined with the Czech national project supported by the Ministry of Interior of Czech Republic, which in University of VŠB participates developing also the post-quantum and quantum solutions for their products. So regarding the organization of the simulator, we took basically the idea from UPM from Madrid, and we followed up this structure basically that was designed and well accepted within the consortium. You already know the picture, you already know the structure. It says that we have some external application or internal within the secure domain asking for keys. They need to communicate with the key manager. There is a Qkd control, possibly to control the devices, the status, the measurements. And then we have later the Qkd systems that are producing keys, chassis, Qkd systems, and also independent forwarding module that is in charge of finding the routes for the delivery or key relay functionality. So we implemented all of these components inside of our simulator. So it took us a lot of time, basically 1 year, to develop the whole KMS functionality. Basically, we implemented the KMS inside the simulator. It's very important to underline this. Also, we implement the encryption functionality, post-processing, and also the VPN consumer application. So in that light, the SI application or consumer applications that can imitate whatever you want. It can be on level 2, level 3, or whatever. It's just important for them to consume the key, to communicate with the KMS, obtain the key, and finally how they are going to use it. It's something that can be very easily set up. Within the project, we developed some of our models as well. For example, we designed the headers that are necessary for synchronization of the keys or communication between KMSs or additional synchronization between SI applications and the KMS. So within this application, the most important and most time we spent basically on designing our own KMS. And currently it supports both versions of the protocols, ETSI 014 and ETSI 004. We implemented our custom signalization within the simulator, communicating between KMSs. And we also implemented important functionalities for KMS, like the key merge, ring resize, stream operations like key stream association support necessary for ETSI 004, collecting information, collecting keys from Qkd systems, and also we implemented waiting queues. We started playing with the quality of service inside the KMS as well to analyze the functionalities of different priorities, different queries of different priorities. Also, we implemented the SI application and users application. That is something new from the previous version because now we support also 004. And we totally redesigned and re-implemented ETSI 014 SI application. So having in mind that now we have basically the KMS that is fully functional, then we can play with it. We can play different tests, different analyzers, and especially with the simulator, we can simulate different number of users, applications, and demands for keys and research. One of the examples of testing is this one shown on slide. So recently, we published an article in conference IEEE in Sarajevo, basically testing the DDoS attack of KMS. So the question is that we all assume that SI application is going to consume, it's encryptor, it's whatever is consuming the keys. It's inside of the secure domain, inside of security area perimeter. But what if someone steals your laptop or steals your mobile phone? He has also all certificates installed on that, and he can very easily communicate with KMS and perform such kind of DDoS attack on KMS. Then we implemented waiting queues, as I said previously, and then by analyzing the waiting queues, by analyzing the requests, we can identify ordinary users, and also we can prevent some of the malicious activities on KMS, asking for too many keys or asking too many often about the status of some impossible routes that they cannot find in the network, and etc. So it allows us a lot of functionalities to test, to play with different aspects that we didn't consider previously. As regards the key generation functionality, we implemented our post-processing functions. We have also the post-processing, basically the full stack, but for the purpose of simulator, we currently use the functions applications that imitate the traffic. So instead of implementing all protocols, BB84 and etc., basically we imitate the traffic that is generated by all these protocols from real devices. We took the formulas from well-known literature about the Qkd link budget, optical fiber loss 0.2 decibels per kilometer. And then within these applications, basically you just need to define then only the key size, the post-processing amount of traffic that is necessary, and some type of like the packet size that is necessary to establish the keys. Finally, when the key is established, it communicates to the KMS, the Qkd systems communicate to KMS and informs that the key is generated, it's ready for the usage, and then KMS can start playing with the functionalities regarding the further processing. So this is the example of this post-processing application. So we have basically the ping pong communication between two sides, and then finally when the key is generated after your settings, after your parameters, here you define the key rate and the sizes, then the key is generated, informed to Bob, to Alice, their KMS as well, that the keys generated can be used. Okay, regarding the protocols, we implemented 014 and 004. So you already know the story behind the applications is communicating with the KMS, asking for status, asking for the possible route. Based on the response, it's going to ask for the key. And then after that, it's going to signal the information to other KMS about the queries, about the key IDs, and then to start the procedure on the second side. We implemented application streams. So basically now we reserve keys, and on both sides, we also signal these informations on both sides that the keys are reserved for the further usage. And also we can play with the quality of service priority queues I already showed, so we can prioritize requests based on priority and serve them and organize different structures of the key request based on the priority. Okay, so we developed the short web interface by simulation, basically, it takes a lot of time when you play with a large number of applications. But it's possible. It depends on your computation power. If you want to play with 100, 1,000 applications, it's possible, of course, no problem. We have the random scripts basically that generate whichever settings you want. It randomly selects the settings of the encryptors, of KMS devices, and etc. So, but it takes so much time. Yeah. So, and to make it more open, as the title of the project, OpenQKD, we implemented a web interface. Whole function and whole simulator is implemented in Docker, and it's accessible via the web page. So I invite you to test. You can go to the URL open-QKD, and you can set up your parameters. You can set up some important settings about the KMS settings. Some of them are only accessible, some of them are shown over the web page, but most of them are not accessible because it would take so much time, and there's a lot of parameters that you can place. So currently just restricted some parameters to simplify the whole settings. It's run inside the Docker, so you need to wait about a couple of minutes, but after testing, after setup, it works very smoothly. So what is the future work? Where are we going to go? What's the next functionality? So for now, we have the KMS function, and basically we can implement independent network, like the whole one stack or one domain, no problems. We can implement key array, we can implement KMS communication, but to go into simulation of large network, for example, European 27, then we were discussing approaches like organizing the KMS or the root KMS, top of the KMS, coordinating all these large-scale Qkd networks, and that's something what is very interesting for us. Now, having the simulator, we can play with different types of the attacks, network attacks, DDoS attacks, rerouting, multi-path communication. We can play with multiple routing protocols, quality of service, signalization, implementation with different technologies like the MPLS, 5G, and etc. We are also currently working with VŠB within the other project. We are going to present it later in the special session about the integration of post-quantum technology and also in Qkd NetSim. And for us, very important option is the emulation mode, because the NS3 by itself, it supports emulators. So basically our KMS that we designed, that we implemented, is available as a real KMS. So we can communicate with that using the Ethernet. And that's something that's currently under development, and very soon we will have that version operatable and running, and it will allow us to test with the real encryptors with our simulator. And then in background, you have the option to simulate 100 users on the other side, what is necessary. So that's something what we are currently working and having in mind, discussing for the future work in the next period. Okay, so we will start now with the examples and demonstrations. This part of the presentation will be presented by Emir from Sarajevo, University of Sarajevo. So Emir, please join us.
Hi everyone, can you hear me? Yeah, good. Okay, so I will share my screen now.
Yeah, please. Okay, just a second, Emir.
Okay.
We don't hear you, just a second. We need to set up the microphone.
Okay.
Yeah. Yeah.
Battery 100%. Connected to heavy. Can you speak again?
Can you hear me?
Yes.
Okay, good. So my name is Emir, and today basically I'm presenting a demo for the Qkd NetSim web interface, which is publicly available at open-qkd.eu, and everyone can experiment with it. In the next 15 minutes, I will be explaining how to use the Qkd NetSim web interface. So I have prepared a video, and today I will do my best to try to follow up the video with my live commentary. Okay, so this is the homepage of the Qkd NetSim web interface, and Here we provide a page on how it works, where you can check how the simulator works in the background. We provided some additional examples and interpretation of their results, so the end users can better interpret their results of their own unique simulations. Here we have a link that leads to the Qkd NetSim webpage, from which you can download the Qkd NetSim on your computer. I think it is the initial version, not this last one. And of course, we have the page on contacts, where you can find our emails for any additional questions that you may have on the simulator. We will be happy to provide you with an answer. Okay, so now we will start the demo. As you can see here, we have the Qkd Key Manager system components selected by default. So what you have to do first is to place 2 markers on the map at the locations at which you want to install these KMS components. So basically with this, you are choosing the location of the 2 Qkd nodes or the secure sites. Here, for example, I placed one KMS component in Ostrava and the other close to Cheshire. And then we go to the parameters to configure the KMS components. Here, as you can see at upper right corner, Docker is starting. So basically the Docker image is deployed in the cloud, and it will be ready in the meantime while we are configuring our simulation scenario. Here you can select the default key size for the KMS systems. So basically the size of the key that is managed in the Qkd buffers. The maximum keys per request you can obtain from the KMS system, and the minimum and maximum key size in bytes that KMS can deliver to the applications. So now that we have the KMS components installed, we want to install the Qkd devices, which will generate the Qkd keys between these 2 locations. So we will go to the add layer, and then we will select the key generator layer. Once we have selected the key generator layer, we will once again need to place 2 markers on the map. From the practical understanding, you want to place them in the closed perimeter of the KMS components. And then we will configure the Qkd devices by going to parameters. Here you can see that the distance is automatically evaluated. So in this case, it is approximately 27.8 kilometers. And based on the distance, we calculate the key rate of the Qkd devices. In this case, it is approximately 31 kilobits per second. Then you can select the size of the key that is generated in each Qkd protocol round. And the other parameters are related to the post-processing applications. So you want to imitate the post-processing traffic. We will run our Qkd devices from 0 to 90 seconds. Okay, then we click apply. So now you can proceed and maybe install additional key generator layer, additional Qkd devices that will generate additional keys. In this case, I will not do that. I will rather install the cryptographic applications. So here you can choose between key consumer layer at C014 and key consumer layer at C004. First, I will install the application at C014. So the application that uses 014 interface to communicate with the KMS system. Now we will configure this application pair. As you can see here, we have some security options for the applications, some parameters that describes the application data traffic, and some options that explains the communication with the KMS. For this application, I selected the SHA authentication and IS encryption. If we select the IS encryption, we also need to select the encryption key lifetime. In this case, I selected the 100,000 bytes. Then we can select the application packet size. And of course, the number of keys that the application will fetch from the KMS via single HTTP request. I will leave it to default, so 3. So now we select the penalty time. The penalty time is basically the time the application has to wait before issuing a new GET key request if the previous one resulted in error from the KMS, stating there is insufficient amount of keys. So we are giving the KMS opportunity to recover. And for the application traffic rate, I selected 100 kilobits per second. And this application will be running from 10 to 70 seconds. Okay. Now I will install different cryptographic application. So we will go to the add layer and select key consumer layer at C004. And we want to place 2 markers in the close perimeter of the other components we have installed. As you can see here, the configuration parameters of the applications are very similar. So for the ETSI004 application, I will now select the most advanced security options, which are VMAC authentication and the one-time pad encryption. Now we select the packet size. And here we have the encryption buffer capacity and authentication buffer capacities. So basically, these are the capacities of buffers that are implemented on the application side, where the application can store a certain amount of keys internally. This helps the application deals with the jitter in the KMS responses on the GET key requests. For the application traffic rate, I will select 50 kilobits per second, and this application will be running from 15 to 80 seconds. Okay. Now we have installed 4 components on each site. So we are close to the limitation of the Qkd Qkd NetSim web interface. We can install 1 additional component. So I will choose ETSI004 application. As you can see here, you get the note that the number of connections is limited to 5 in order to speed up simulation processing time. If you want to simulate more connections, you would need to download the simulator and maybe use some of the example scripts that we already have. We will configure this application very similarly to the previous one. However, for this application, I will leave the application traffic rate or the data rate to 20 kilobits per second. So it is a less heavy consumer. And this application is running from 10 to 50 seconds. Now we can start our simulation process. So this process may take a while. Here I cut the video, so it will be really quick. Okay, so this is the results page. As you can see here, we are first examining the key generator layer. On the lower pie graph, you can see the total amount of keys generated versus total amount of keys consumed. In this case, it is almost 50-50, so we are consuming as much as key material as we are generating. On the upper graph, you can see the amount of key material available at the Qkd buffer in the simulation time. So as you can see, we have key generated until 10 seconds. In 10 seconds, we have our first application started. So we have some key consumption, but these are not heavy consumer applications. Still, the key generation is a lot higher than the key consumption rate. In the 15 seconds, we have our second ETSI004 application with 50 kilobits per second data rate and the most advanced security options. So the key material is really quickly consumed from the Qkd buffers. And in the meantime, we have the fight between key generation process and the key consumption process. So the Qkd buffers were running low. Then we can check the performance of the application. First, we will start with ETSI014 application. Here we have some key consumption statistics. And then we have some Qkd application statistics. Here you can find the parameter missed send packet calls, which helps the user understand if the application had any interruptions in the data traffic due to the lack of key material. It is also depicted with key data utilization parameter. In this case, it is 100%, which is not true. We will see that later from the graph on the left side. It is now fixed in the version you have now available and running. Here we have some Qkd application KMS statistics, so the amount of data exchange between the application and the respective KMS systems, and the signaling statistics, so the data exchange between the applications for the signaling purposes. On the graph here, you can see the key consumption of the application in time. So the application obtains 3 keys initially and proceeds to consume these keys for some duration of time. Once the keys are consumed, the application submits a new GET key request and obtains 3 additional keys, etc. This can also be seen from the graph below. So if we turn off the application data traffic, we can see this communication between applications and their KMSs, and also the signaling application between 2 applications at the times where we have the key updates. Now, if we turn on back the application data traffic, we can see that indeed the application had some interruptions in data traffic. This interruption happened in the key update intervals. Okay, so now we will proceed to examine the ETSI-004 application. This is the application that ran on 50 kilobits per second data rate. Of course, same key consumption statistics, Qkd application statistics available. Here we can see that the application experienced a lot of interruptions in the work due to the lack of key material. So the key data utilization was only 54% in this case. And of course, you can check then the Qkd application KMS statistics and the signaling statistics. Here, if we turn off the application data traffic, we can see that the application is constantly communicating with the KMS system. This is because we have selected the most advanced security options, one-time pad encryption and VMAC authentication. And we use ETSI-004 interface. If we turn on the application data traffic, we can see that the application was running perfectly until some point of time, I think in 22 seconds. And then the application starts to experience the interruptions in the data traffic due to the low key material, the lack of key material from the Qkd buffers, basically. We will now go to, okay, let's see, in 22 seconds. So now we go to key generator layer, and we will see that this is the exact point of time where the Qkd buffers were running low on the key material. This can also be seen from the graph above. So we have the key consumption of the application in time, which is represented by a linear line. And this line has one steam until 22 seconds, and after 22 seconds, it has lower steam, so lower key consumption. And this is the other ETSI-004 application, the last one. So once again, key consumption statistics, Qkd application statistic. This application had overall better key data utilization, 71%. I think this is mainly because the application was running on 20 kilobits per second rate. Once again, on the graph on the left side, you can see the application data traffic, how it behaves. So the application is running perfectly until some point of time, and then slowly starts to experience the lack of key material. The same can be noticed from the key consumption in time of the application. So in ideal case, this line would be straight, had one steam from start to the end. But in this case, the steam of the linear line changes in maybe 24 seconds. So the application has a lower consumption rate. And basically, this means that the application could not achieve the desired data rate of 50 kilobits per second. Here, I will just say that in the case if you installed additional key generator layers, you will need to track them, separately, each Qkd buffer that you have installed. If you want to reconfigure the simulation, you can also do that. You can go to the parameters and change some of them and start the simulation again. Or you can even go and remove some of the applications and see what happens in that case. So this is basically it for the Qkd NetSim web demo. And now I have one additional example. Okay. It is presented here. So for this example, we used, let me just move this, okay. So for this example, we used the console approach because we had more freedom in configuring the parameters, and we can install more than 5 connections, basically. So as you can see here, we have the site A and site B. Each site has a signed KMS system, and we have one pair of Qkd modules that are generating keys between these two sites at the rate of 80 kilobits per second. And the size of the key that is generated is 800,000 bits. We have installed 5 different cryptographic applications that consume key in their own manner. For the application 1 and 2, we simulate the network traffic of the VoIP applications. We have selected the most advanced security options because the nature of these applications and the security options we have selected, we chose the ETSI-004 interface for the communication with the KMS system. The application 3 is an example of video application with IS encryption and with relatively frequent key updates. But because the key updates are not as frequent as in one-time pad encryption, we have selected ETSI-014 interface to communicate with the KMS system. In this case, the application will obtain 2 keys per request from the KMS systems. The application 4 and 5 are example of some VPN tunnels with higher data rates. Once again, we use IS for the encryption and practical key lifetime of 64 gigabytes. For the same reasons, we have selected ETSI-014 interface. However, in this case, the applications obtain only 1 key per request from the KMS system. So now that we have the topology in place and the configuration of different parameters, we have yet to configure the simulation time. So it is presented in this slide here. As you can see, we are running video application and 2 VPN tunnels for the duration of 5 minutes. And we have 2 VoIP applications running for 2 and 3 minutes respectively. The simulation time was approximately 6 minutes, and the Qkd devices were running constantly for the whole duration of the simulation and was generating keys between these 2 locations. At this slide here, we can see the results. So we can see the total amount of keys generated, the amount of keys consumed, and the amount of key material that remains in the Qkd buffer at the end of the simulation, so around 6 megabits of key material. On the right pie graph, you have the comparison of the key consumption between different cryptographic applications. As expected, the VoIP applications, which use the most advanced security options, consumed the large amount of key resources. And from the statistics shown below, you can see that VoIP applications were running perfectly, did not experience any interruptions in the data traffic, which is perfect. And for the application 4 and 5, for example, we have some missent packet calls. So we had the interruptions in the data traffic. However, this happens at the start of the applications, while the applications were trying to obtain the status information from the KMS system and until they obtain initial key material. Because the application 5 has the higher data rate, of course, it missed more calls than the application 4. The same explanation applies to the application 3, video application. However, in this case, some of the missed calls are a result of the key update periods. So that would be it for the demo of the Qkd NetSim. I would now like to pass the final words to Professor Miralem to conclude the presentation. Okay.
Okay, thank you, Emir.
You're welcome.
Second. This goes, well, basically. Yeah, okay, so basically that was a short presentation of the simulator, the current version. We just shortly present the web interface, but in console-oriented interface, we can simulate very large networks, and we can simulate with different multiple topologies. That's something what we are going to do within the rest of the project, and also focusing on emulators and simulating the within the national supercomputer in Czech Republic. We can basically simulate multiple scenarios, whatever is necessary. Okay, so if you have any questions, we are open, and also please send your questions to emails if you have some other proposals.
Very nice presentation. Also from your PhD student, on live. Yeah, I don't know, is there any questions, comments to Nivelem or from the online audience? Please wait 1 or 2 minutes before you start talking. So we are connected, so if you have any comments online, please go ahead now.
Emira, I think you were trying to say something,
but you're
muted.
No, I think maybe somebody had a question, but I could not hear very well from your side. So it's nothing.
No. Any question here? No.
Yes. Right. So did I understood correctly that you have up to now only single links to simulate, right? So is there any chance to have a network, an access network, a backbone network in future?
Yes. What we are currently working is basically keyed away functionality. That's what you are proposing. Is we need to have a keyed away. But for that purpose, we need to have KMS to KMS to KMS to KMS communication. And that's something what is currently under development. It will be very soon developed. This functionality supports basically connecting multiple domains, connecting multiple autonomous sites, secure the perimeters. But the current version supports only 2 independent sites to connect via direct KMS connection. So we can basically connect pair of KMS, pair of KMS, pair of KMS, but currently we cannot connect them, but it's going to be resolved for the next version.
Thank you.
A question maybe to you or to Emir. When you set up the Qkd link, basically the distance you got from Google Maps, I guess. What about the key rate? Because I guess it basically just takes into account some exponential decay of the fiber, but is there some possibility to either play with the starting, so the initial key rate, and also to change the loss in the fiber, which might be different because it depends if you have a pretty new fiber or one which has a lot of slices and so on. So is a possibility to basically make those changes in the simulator?
Well, in the console-oriented approach, yes, but in the web interface, currently no.
Okay, that's the thing. Okay, so you have to really download.
Yeah.
Okay, yeah. So on the web. Okay, that's good. So on the web interface, what are the parameters?
It's calculated based on the formula, basically from Andrew Shields. On their link budget calculation, and they use the optical fiber distance of 0. Yeah.
And they start with 10,000 bits.
Yes.
At 0.
Yeah.
Okay. So basically, the console is much more can be much more it's more flexible. It can be configured.
Yeah, because there are a lot of parameters to play.
Yeah, no.
In applications, in KMS, in everything. So we just reduce some of them to simplify on the web interface.
Okay, very good. Yeah.
Yes, sorry, I have a question. Maybe I missed it. On the hardware side, the Qkd boxes. So what information do you need from the Qkd box to be put in the simulator? Is it sort of a fixed, for instance, do you want the key rate as a function of the distance, the sensitivity to loss, to which degree of detail do you want to specify the box to optimize its insertion in the network, for instance, putting more boxes, or less boxes, depending on how they react on distance and things like that. Is it taken into account, or to which degree of detail?
At current level, we take only the distance, the key size that plays the basically that defines the key rate, and we also take into account the average post-processing traffic exchange over the public channel. So, but with that parameters, you can imitate either you use LDPC, Cascade, Window protocol, or something else for error reconciliation. But for quantum channel, we basically take the distance and we take the key size as a fundamental parameter.
But is it a fixed distance and a fixed key size, or do you take into account?
No, you can change that.
Sorry?
You can change that. You can modify it. Distance you change by the pins on the map or the kilometers distance that you define.
I think maybe, if I understand correctly, what Philip is asking is how dependent your simulation is on the performance of the Qkd system. Like, how does it come into the simulation?
Typically, you don't get
the range and the rate and all of this stuff, right? Is this what you're asking, Philip?
The key rate is a function of distance, typically. Yes. So there is a, do you take this sort of curve, key rate as a function of distance, and try to optimize not for a fixed key rate and distance, but optimizing on that, how you will distribute your Qkd boxes, for instance, things like that. Is it done or not done?
But this rate versus distance depends on the product, right?
But it mainly depends also on dark count rate. That's
on dark count and stuff.
Because you take basically, I don't know what curves are in there, but I mean,
average Qkd key rate.
The loss is first, of course, the exponential, but then it basically has the sharp drop off once you hit the.
Do you have time to open? If you wish, I can.
No. It's okay, but I think the question is really, I mean, how realistically I think is the link.
So can I answer
how realistically can you make the link? Let's put it rather than this question.
Can I answer the question?
Go ahead.
Okay, so we are trying to simplify the Qkd process itself. So we are not, focusing on the quantum layer. We are trying to just imitate.
You're kind of abstracting
Yes, we are trying to imitate the key generation process. So the most important parameters in the console is you just select the key rate and the average size of the key that is generated in each Qkd protocol round. So it will determine the time interval between which the Qkd key will be generated. So this is the most important parameters to Qkd net simulations.
Yeah. Philip, I think what you can use the tool for is really to try to simulate what's the lowest key rate you can have in order to run all the applications in the network. Yes. And with this, you basically then you can go to the suppliers, exactly build your system to basically reach that.
So with this, you can identify if some of the links need to be upgraded with higher key rates, or even you can see if how much storage of the key you need in advance to support, higher traffics.
Okay. So it's a rather high-level description of the Qkd.
Yes, it's very high.
It's really, it would be very difficult to implement all the protocols, BB84, B92, continuous
rate, and you say, okay, we'll do whatever you want, find this rate, however.
Then we need to somehow implement that rate.
We will need a lot of time to implement all this. So this was the simplified version, and I think it's much better for this current purpose.
Okay, thank you.
Okay, I think we say thanks to Amir and Demir.
Thank you.
You're welcome.